How's it going, everyone? Oliver Gonzalez here again, exploring at the functional like JavaScript. This particular approach to now write code in a way that is much more descriptive by using and standing on top of the mathematical proof. So we don't need to actually know and understand these mathematical proofs. We just only can use these tools in our language when we are writing our code to actually focus on what we really care, and that is functional business logic, right? So the whole point of this is that would it be nice to that piece of code, that narrative that you're telling, work as it needs to be? And this is also part of the testing when you are combine this with object-oriented programming. So the point here is that with functional programming, we want is to be sure, thanks to the mathematical background, the mathematical foundation, bedrock, that every time we use these particular tools, we guarantee that will work as expected. So we only care that what this stuff output, what is the output of this function and why it does that. So because we went through a quick overview of a little bit of history of the evolution of software architecture, as well as another interesting video of the woven on the loom of sorrow, the evolution of computing and conflict, and how that both of them were made by Grady Butch, which was the inventor or one of the co-creators of the Butch method, which is the way of how now you can combine is or in other words, let's take a look at the world from different lens. So instead of looking at as processes, which is the way of how you decompose systems, now let's take a look at the atoms, right? And from here, by now, be able to describe the real world as atoms, as this small unit, so we can compose the universe. Then we now dive deep into what we really care and all the little bit of history to understand how do we get here, right? Starting from the House of Wisdom in Iraq, then passing through the Middle Age with Da Vinci and all of these techniques that were used back then for war, initially as a companion, and also like Galileo and how he actually now earned his money, and it was mainly because he has now the military contract with Vienna. So he developed this particular artifact to now provide their troops an ability to look at the enemy at a distance, far from away. And they now how that connects to the Industrial Revolution, at least happening in Europe, and how now techniques and all of these tedious computations were now shrink that. For example, that helps sailors to navigate is the world, okay? In a way that, now save time for knowing those computations. And this is what the John Napier and the logarithmic table actually come up to avoid this repeated multiplication and all of this calculation that you need to do. So then, because John Napier and people around in the mathematical fields actually now wants to find ways to process and to compute stuff, right? it was also the development of this initial way of computation. Ada Lovelace also was one of the first programmer ever on a thread mill, on a thread machine. And then how that now leads to, for example, to the alliance that were back then before the first before the Archduke Franz Ferdinand was killed, now collapse, and that now start the first war. Something that also now the computations was not only seen as a companion but more like an instrument, and that now it was intensified because of the because of the Great Depression in 1929, and with the rise of fascism on Europe, that leads to the Second World War, where that it was now the mathematics was used as an instrument of war, of conflict. So why am I mentioning this? Because with the development of all of these techniques, machines to actually decode the and listen to message from Germans, with the enigma and also the mathematical aspect of this with Alan Turing and all the people involved in the projects to decrypt this message from the Germans. And once the Allied forces win the world, now they invest heavily on defense, and they create now companies to do that. So for example, like the Rand company, and also that now is a golden era of the computing and the software engineering. So because that where because after the war, the Second World War, both axes they now invent some of these computation systems, but at the end of the day, now on the West, it was where it created the environment needed to actually develop this kind of machines. The Fairchild actually now make that possible. The 8 treasures actually leave that Rand Corporation to actually create now Fairchild, and therefore now give us these small devices that can now perform a lot of computations for us that are not embedded on any of our device. I'm talking about is these silicon chips. So all of this is great, interesting, fantastic, because it did explain now how do we get here in the evolution of computing and the software engineering. And because I'm going to be someone that needs to provide my service, and I'm going to provide my service initially as a web developer, the front end and the back end, and then to other technologies. But the TLDR is that because in the 60s, when people now write all of this application in this functional way, or in this procedural way, to decompose now systems through algorithm, one step after the another and another and another. The thing here is that, well, that actually help us and lead us to the development of techniques or way of strategy that allows to make those applications easy to reason about. Okay, So also during the 60s and the 70s, with the rise of multi-language, multi-computer systems, uh, in different locations, and with the rise also of the distributed computing, the beginning of the distributed computing, which is something that now as a JavaScript developer we know that for sure. We can now is learn from all of these mistakes and, and good trials. So we can learn from their mistakes and therefore move on to what we really care, and that is the functional approach, especially on how can we apply that in the JavaScript world, in our JavaScript applications. So this is something that is not new. It is a pattern that predate way JavaScript, that allows us to write these stories in our code, describe how the things work in a descriptive way, and we know that we work for sure because it is based on mathematics. So and again, I make a huge overview of all of this. It's just to now finally get into what we really care, especially if you're gonna learn something that you might feel in the pit of despair. And there also will be attention to go back to what is to what we are familiar with. But if you keep pushing and understand why we need to use that, you will get what you need to. And here in today's video, let's going to now explore is this code is provable, or the code overview. The nuts, the boots, the carabiner.
Here's a quick overview of what to expect. We're going to start first with functions, because any discussion of function programming, you probably need to understand functions. Here's a little bit of a hint. You probably don't know what a function is. I said. I've been doing programming for a long time, and I didn't know what a function was. Basic. So we're going to actually dig into functions way more than you're used to. We're going to look at all different sides. We're going to look at closure. You've probably heard or given that job review at some point. I would venture to say it is impossible to understand functional programming. I have heard many people say, oh, I understand functional programming, and what they mean is I use an app to reduce. That is a little piece of it. That is one of the pieces of the equipment. But it is not sufficient to find them out. Closure is one of the most critical pieces.
Yeah.
Composition, the way the data is flows is that we look at immutability, how we manage changes to values in state and time. Management of state change is one of the big key ideas of almost every framework, every programming paradigm. They have some idea of what you want to do with managing state and time. That's really what programming is. It's a state change. It's managing state and time. Functional programming is a very specific way of thinking about it. Recursion is one that kind of scares people, similar to if I'd thrown up your regular expressions. If I'd said regular expressions, somebody'd be like, I want to do regular expressions. It's okay. Recursion people, similar to if I'd thrown up your regular expressions. If I'd said regular expressions, somebody'd be like, I want to do regular expressions. It's okay. Recursion is useful and important. Not that you can solve every problem. It's very useful. It's special. Then we will finally actually get to look at the map filter reduce. That thing that everybody calls functional programming. You can look at that and where it fits in, but you won't understand or appreciate where it fits in unless you've got these other pieces of equipment. And all of that will have taken us to the question of how do we operate on a functional way? How do we operate on values right now? The values that we have right now. Guess what? Our programs all have values now, and they all have values they will have at a later time. There's always a time. So how do I apply functional principles over time? How do I do asynchronous programming? there's lots of ways to answer that question, but the one specific way we're going to answer that in this course is we're going to look at adapting functional principles over time with
Mm-hmm.
we'll end the course by taking a look at some of the, just a few, of the libraries that you might choose to use when you want to go out and start doing your own functional programming. You need a library and helpers to help you with that. We'll look at that. That's what to expect. It's a deep journey, okay? So buckle your seatbelt. There's lots of it. Before we jump into the course, you should definitely hear my thoughts on coding.
Oh. Hmm.
So functions. What are we in for in this course? Before we jump into the course, you should definitely hear my thoughts on coding.
Okay, so let's get into this. Yeah. So functions, right? There you got it. Functions. Function purity. Okay, so functions versus procedures. Functions versus procedure. Procedures. And this is why we make this quick overview about understand that how can we decompose systems. And one of them is through algorithm, through processes, okay, and the other is through functions. And now we also look at the word of objects, or these atoms here.
What is a function? Is it just the function keyword? True story. In my book, remember I talked about the functional life book. In my book, I had started a repo. This is actually how it happened. I was in Poland. And I had to write functional programming, but I kept saying, no, I'm not qualified. I don't know how to do that. I'm not going to write it. I'm the least qualified person to write functional programming. But I got this weird idea in my head. I said, maybe I could write something about functional programming, sort of from the perspective of how somebody learns something that would be useful. So I started a repo, and I didn't tell anybody about it. And I did as I do with all of my books, which is everything's out there for free. I just started writing and committing to this repo, late at night in Poland. And I wrote a sentence at the beginning of chapter 1, and that sentence basically said, almost verbatim, it said, functional programming is not all about functions. And I committed. That was the purpose. Remember, I hadn't told anybody that I was doing this. Before I came back to the repo, because I was teaching, I said, before I came back to the repo, somebody had found the repo, so several people had found the repo, and somebody had filed an issue on the repo. And when I opened the issue, paragraphs of, what are you doing? This is terrible. I cannot believe there are decades worth of pedagogy on the topic of functional programming, and you are completely spreading misinformation and telling people functional programming is not all about the functions. It's absolutely, it's all about the it's touring. It hurt my feelings for about 5 seconds, and then I smiled because I realized I must be doing something right. I upset the
Exactly. Exactly, man. Because it's like that, man. Mm-hmm. That's particularly feedback.
Now that sentence still exists. It's the first sentence of chapter 2, and it's been slightly modified to clarify because I had a whole plan of what I was going to say in chapter 1. I hadn't written it yet. That was like my
I haven't written yet.
Keyword, my buzz line, catching attention.
The catchphrase.
That sentence now is the first sentence of chapter 2, and it now says, functional programming is not all about function. Because that's what I meant. I've been using function keyword all over my programs, but that doesn't mean I've been doing functional programming. Here's a function called add numbers. It takes in an X, Y, Z, and a W.
Mm-hmm.
It adds those together to a variable called total, and it prints it out to display. Well, it's using the function keyword. But the question is it functional? And then we've got extra numbers, which takes in some other inputs. The .args, by the way, if you don't know that, that's the rest syntax.
Is the rest syntax that they tag gate all of the
seems to basically be calling
arguments
adding in a few other values
into an array?
wrapping around columns, with some other inputs. The question that we need to confront, the most critical question we can probably answer in this entirety, are those functions? And if not, why not? So let's look at add number. It clearly does take some inputs. X, Y, Z, and W. And it clearly does do something with those inputs. It adds them together into a total, and it even prints it out to the console. Think about it, it's the DOM, it prints it to the console. It's doing something. That seems like at least a minimally base level line, that it's doing something with some input, so it's kind of like a function. Not exactly, because the bar for being a function is higher than that. If you're thinking about this in Venn diagram sense, we've got this bigger outer bubble here of something, and we've got to figure out what that's called. And then there's an inner bubble inside of it of things that qualify as functions. And this particular add numbers is in the outer bubble, not the inner one. It's not a function, so what is it? Best term you can use for it is a procedure. A procedure is a collection of operations, a collection of things that you need to do in the program. We all use procedures because we all need to do stuff in our programs. Okay? Just because it uses the function keyword doesn't make it a function. It at least makes it a procedure. Procedures, of course, can take inputs, they can return outputs, they can do things like print to the console, they can be called multiple times. There's lots of benefits to procedure. But it's not called procedural programming. There's a whole thing called procedural programming. We're talking about functional programming, which means we're going to have functions. So what's the difference? Well, to understand the difference, and we're actually going to uncover this across the next several sections of our discussion, we're going to begin to understand that question, what is a function? By first saying, a function not only has to take some input, it has to return some output. Not just print it to the console, it has to return it. In other words, if it doesn't have a return keyword, it is most definitely not a function. So any functions that you have to return it. In other words, if it doesn't have a return keyword, it is most definitely not a function. So any functions that you have that don't have return keywords, those are procedures. Now that's not a complete definition of function. We're going to evolve that definition over the next quite a bit of our discussion. And that evolution of that definition is not going to change or replace or make that statement valid. It's more like if I was holding up a Rubik's Cube. And if we looked at only one side of the Rubik's Cube, we'd only get part of the story of the puzzle, right? Right now, that's just one side of the Rubik's Cube. We've got to look at all sides of the Rubik's Cube.
Rubik's Cube. I like that analogy.
It's not only got to take some inputs and do something with it, it's got to return something. Okay? What about extra numbers? It definitely has a return keyword. So, is it a function? Well, you notice that it's taking some inputs, in this case X, and then it's got a number 40 that's hard-coded, and then the rest of any arguments are passed along in R. It's passing those along to this other thing called add numbers, and whatever that thing returns, which from the perspective of line 7 we don't know or care, whatever it returns, we return. So, is extra numbers a function? It takes inputs, it does something, and it returns some sort of output. You may be aware that in JavaScript, all functions minimally return the undefined value.
The undefined value,
so
exactly.
Returning undefined. Right? You see on line 3.5, there's no return value. So it's returning undefined. Well, there's a different side of the Rubik's Cube, which is extra numbers is not a function because functions can only call other functions. Functions can't call procedures, or boop, they become procedures.
Exactly.
Okay? If you have a thing that is not a function and it's called by something else, that pollutes that something else to not being a function. It makes it a procedure. It doesn't make it bad. It doesn't mean that you should delete it from your program. It just means it's not a function. And if it's not a function, it doesn't get to play at the party of all the functional programming stuff that we're going to learn. It has to be a function. It has to be the number 1. If we're going to add 1 and 1 to get 2, like this is one of the characteristic identity things that has to be true, because you can't do any functional programming with a thing that's not a function. That sounds obvious, but we need to state that very clearly. It has to be a function for you to take advantage of functional principles. There's a lot of ways that people use things that look like functional APIs and they look like functional patterns, and they don't do them with those true, honest-to-goodness functions. And that's not really functional. Okay? It's masquerading as functional. So both of these don't qualify because both of these violate some aspect of what we mean about a function. It's not just we have a keyword there. And just because it uses the word function, they call these procedures. What about this one? No, we have a keyword there. And just because it uses the word function, they call these procedures. What about this one? We have a keyword there. And just because it uses the word function, we should still call these procedures. What about this one? Tuple. Okay? If you don't know the term tuple, it's like you might not have known the word character. in JavaScript. Here's more formal and other programming languages, but here you just think of a tuple as
Some procedures.
like 2 values in an array.
Procedures.
Okay, this function takes in an x and y, and it produces a 2-element array, a tuple.
Unlike
X plus 1
function, they don't
so if I call this tuple function
return
with the array 5
something.
I'm just doing some fancy stuff here to show you.
They are just, and I get it. Procedure unlike function, they don't return something. They're
It's
just
going to produce an array that has the values 6 and 9.
receive
Because 5 plus 1 is 10
inputs,
It's going to produce an array of 6 and 9. Now look what
perform
I'm doing with 5. I'm
some
bringing back
operations,
an array
but doesn't return anything.
here that I don't actually care about. Line 5 is using a destruction syntax. The destructuring syntax says, hey, whatever array you get back, what I actually care about is the individual element.
Of that.
2 individual elements. Give me those 2 individual elements, call them A and B. That's what I care. So in essence, what I'm saying as a programmer, what I'm communicating to the reader of my code, is that tuple actually has 2 outputs. I'm saying I don't care about the one array. What I care about is the 2 individual values in it. It's got 2 outputs. I'm going a little beyond the technical definition of a function to say it takes some inputs and returns some outputs. One output, or in this case, depending on the style of coding, put in and return some output.
Again, and according to you, my friend, right? And according to you, which is what we really care at the end of the day. You know, it's like, here we have a function. Since it receives inputs and return outputs. It's pretty simple. It's pretty simple. It's pretty simple. Functional name semantics.
More to it than it just takes inputs and does something and returns something out. Because
Function name semantics. Function name semantics. Here we are. Semantics. Because what this stuff, what is the output of this, and why this stuff doing this?
if I took some inputs X and Y, and then just on line 2 I said like return 40, I'm going to go out on a limb and say that would really, in the truest spirit, take inputs and return a value, but it really wouldn't be the spirit of a function. And to understand the spirit of a function, you really have to get back to the math. I promise I'm not going to teach you a math course. We're just going to dip our little toe into this math just briefly so that you can understand the spirit of a function program. Does anybody remember this kind of stuff from like 8th grade? The way I remember this is the TI-85 graphing calculator where we plug a thing in and do things.
Yep.
I remember this kind of stuff, and I remember it used to look like y equals 2x squared. I remember for months learning about these things and just randomly coming up with numbers that meant absolutely nothing. They were just completely abstract, not comprehensible. And then we pulled out a graphing calculator, and wow, all of a sudden this thing actually meant something concrete. But I wish at that time, and I wish now, kids that are learning this stuff, I wish that somebody would say, hey, guess what? There's a concrete thing that's happening, which is that you're taking an input value, in this case an x coordinate, you interpret the input value as an x coordinate, like the input value 1. We're going to put it into this thing called f of x, which is a function of x. I wish somebody had said to me, hey, you know how you do like programming? This is kind of the same thing. Like you put in an input and it's going to give you an output. Nobody connected that dot to me at all. I wish they had. So I've been a lot further along as a programmer if somebody connected it to this kind of stuff. But I remember plugging in the number 1 or the number 2 or the number 3, getting these other numbers out. Like 1 gives me the number 5 and 2 gives me the number 11.
So what you're doing is that you can map easily all of this, man.
It would draw this same parabola.
So this functional programming is help you to mapping stuff.
X input value, the input value is the X coordinate, and when you take the input and the output together, we can interpret their meaning as a parameter. So what is a function? A function is a relationship between the input and the output. There's a semantic relationship between what I put in and what I get out. If we were to write this in JavaScript, we could just write function f and pass in an x and give back some other thing. But what would be a better name for that function? How about parabola? To describe to the reader of our code the relationship. The relationship is you put in an x coordinate, you're going to get a y coordinate. That's why I said a slide ago that just returning 40 isn't really the spirit of a function because there's no relationship between the inputs and that output. That doesn't mean that something returns a number that it can't be a function. It just means that it matters if there's an obvious relationship between them.
Exactly, relationship where you can mapping between the input and the outputs. Function name semantics. So the goal here is to create relationships or mapping the inputs with the outputs. It might sound silly. Okay, it definitely might sound silly. But this is what I'm doing all over my life. Doing generalization. Even though that I'm wrong, which is I love it. I love to be wrong because there is an invitation to correct that.
The goal is to create relationships that are obvious to you. So, function is the semantic relationship between input and output. Here, if I
And computed output, man. So a function is a semantic relationship between the input and the computed output, bro. So function is the semantic relationship between input and computed output. Absolutely, man.
make a function called shipping rate. The name of the function tells you the semantic relationship. If I put in size, weight, and speed, I'm going to get a shipping rate back out. That's what it's for. That's what functional programming bases itself on. That everything that we use, some people metaphorically refer to them as Legos. Every Lego in our app has to have a name that describes the semantic relationship between input and output. You have lots of functions, aka procedures in your app. Probably tens of thousands.
Mm-hmm.
How many of them, if you go and look at the name of the function, should you be able to understand the name of the procedure? How many of those should you be able to clearly understand the relationship between inputs and outputs? How many of you can produce something?
No.
Most of them probably do. a lot of other things, really useful things like
exactly.
you should be able to understand.
How many?
You have lots of functions, aka procedures.
You have functions. And this kind of clarification and specifications is important, especially if you need to produce outcomes. And that's exactly what I would like to do, to produce outcomes, to get, to offer, to show what it needs to be done. So you have functions. So you have a lot of, so you have a lot of functions. And I get it. So you have a lot of functions in your code, that most of the time they are just procedures, aka procedures. Takes an input, do some computation, and return, and doesn't return anything, and doesn't return anything, right? Or it might return something that is not related to their inputs, because perhaps you're modifying its state of another place.
How many of them, if you go and look at the name of the function, would you be able to understand the name of the function? How many of those would you be able to?
How many of you? Okay. Yep. How many of you?
How many of them, if you go and look at the name?
How many of you, when you look? Yeah. How many of you, when you look at the name of those functions? Okay. How many of you, when you look at the name of those functions, can tell that that function can tell what that function does, what that function does?
Would you be able to understand the name of the function? How many of those would you be able to clearly understand the relationship?
How many of them would you be able to describe the relationship between inputs and outputs?
How many of these would produce something? Most of them probably do a lot of other things, really useful things like writing to a database and all that. But not a lot of them probably return you a value. So you have to put some special sunglasses on if you will, start looking at the code around you.
So you have to put some special sunglasses when you look at the code for that. So when you look at the code around and asking this question, if they have a relationship between their inputs and their outputs.
Is it taking an input?
Mm-hmm. Asking this question.
And by the way, no input is a valid input. It doesn't have to have an input. The absence of an input is a valid input. But is there a semantic relationship between what I put in and what I get out? And by the way,
Mm-hmm. It is a semantic relationship between what I'm putting in, what I'm putting in, and what I'm putting out. A semantic relationship between what is putting in, whether it's not having a parameter or input, and what is putting out.
undefined is a valid output as long as there's a semantic relationship to the input. If I have a function whose job is to take an object and try to get a certain property of it, and that object doesn't have the property, the proper correct semantic return value would be undefined. Would it not? That's entirely consistent. And that object, as long as there's a semantic relationship between what I put in and what I get out. And by the way, undefined is a valid output as long as there's a semantic relationship to the input. If I have a function whose job is to take an object and try to get a certain property of it,
And try to get a set of property.
The proper correct semantic return value would be undefined. Would it not? That's entirely consistent with function programming. There has to be an obvious semantic relationship. We're not doing that. How many of you have heard the term side effects? Okay? So what we're getting at, what we're scratching at here, is that in functional programming, for there to be a function, it's got to not have side effects. But what does that really mean? That word gets thrown around, that term gets thrown around a lot. What do we really mean by that? Well, it's more than you do. Number one, if I were
So, that'll be all for this video. Take care. Bye-bye.